Hello and welcome to this hands-on exploratory data analysis video. We're going to be diving right into some real-life EDA using a data set called diamonds. Now, before we get started, let's go ahead and load the packages that we're going to be needing. So these are pretty much the standard packages that you'd be using for exploratory data analysis, right? You have ggplot2 for visualizing, you have tibble for dealing with your data, the data frames, and then we have dplyr for the actual functions used in manipulating the data. So let's go ahead and load all of these. So just go ahead and write diamonds. We can actually just very quickly find out, because I also forgot. Okay, so there we go. It's part of the ggplot2 package. So diamonds comes with this package. It's a data set that contains data on diamonds, basically. So let's actually go ahead and print it out first before we go into any more details on what this data set is. And there we go. We get this data set. We see that it has almost 54,000 rows, and we have, some columns here. And because of the name, it's very clear, it's a data set and it has to do with diamonds, the carat of a diamond, the cut of a diamond, the color, the clarity, the depth. Those of you familiar with diamonds, these are important characteristics of diamonds that are used to measure the quality of diamonds. And then the price and these X and Y, Z values. So right off the bat, you have to know what you're dealing with. You have to be familiar with the domain and that kind of stuff. So if this were a real life problem, right, what you would do as part of your exploratory data analysis would be to go into Google and search for this stuff, right? Become an expert. Know what color and clarity and cut and all of these mean. What it means for a diamond to have a certain characteristic. How do you determine which one is the best? Is it enough that it has a high carat value, or is clarity as important as color? These are all questions you should be asking yourself. And before you even touch the data set, right, you should go and learn about this stuff, right? What does X, Y, and Z mean? In our case, we're lucky because this data set comes from a package, so it has documentation, and that's how we pull up the documentation. It's pulled up here. So here, we have basically answers to most of our questions. This is the price of over 50,000 round cut diamonds, a data set containing the prices and other attributes of almost 54,000 diamonds. The variables are as follows. So we have the price. It's in US dollars, and it's giving us the range. They don't need to give it to us because we're going to find out on our own now. The weight of a diamond, that's what carat refers to. See, that's something I didn't know personally. A carat means weight. Cut is the quality of the cut, and these are the possibilities. Again, we don't need to see this because we're going to be finding out all of this information by ourselves through our EDA. The diamond color from D, so D is the best apparently, and J is the worst. And then clarity, the measurement of how clear the diamond is. L1 being the worst, or is that I1? I'm not so sure. All the way up into IF, which is the best. And then, so it turns out the X, Y, and Z variables are measurements of the length, width, and the depth of the diamond. And then we have table, which is the width of the top of the diamond relative to the widest point. So that might come in handy. And then the total depth percentage. So, and that's, calculated using this. So this is actually a column that is created using other columns. So it's not, a pure column. It's an aggregate of other values. So this gives us some information on the data set. And as you know by now, there are other ways to also, get a glimpse, if you will, of your data set. So we can use a glimpse function. And if you remember, glimpse is from the tibble data set, but it also there in dplyr. And then, this way we get to see as many values as possible for each variable. And then we get to see the type of the variables, and then the number of variables, number of rows, and these are the names of each variable. So that's a very useful function when starting out off with exploratory data analysis. It might be more useful than this because here you might have to scroll through the columns and that kind of stuff, but here you see all the columns very clearly. Built-in function that you guys are familiar with is summary. which gives us some statistical summaries of more specifically the numerical variables. So for example, caret, we can see like the mean value of caret and the range. And this actually corresponds to, like, if you go into price, right, we have from $326 minimum up to $18,823. So that's this right here, right? We come into caret here. So it's from 0.2 all the way up until 5.01, right? That's the range of the caret, so on and so forth. So this gives us a very good idea of the ranges. And here we see the counts of each clarity type. So we see that SI1 has the highest count. That clarity value appears the most, so on and so forth. So you have to take a very good look at this and get a good sense of what's going on, and get, we see that ideal is the most common and fair is not as common, but very good and premium are surprisingly not as rare as one would expect, so on and so forth. So there's a lot of information buried in here. My job here is just to give you, tools for how to do EDA on your own, but you should, focus on understanding what's going on here. And whenever you have a new data set, spend time here, make note of important things, make note of things you would like to explore further in your analysis. There's also a built-in function called str, which stands for structure. And this is basically the built-in version of glimpse up here. So, instead of structure, you could just go ahead and use glimpse, which is just cleaner and gives you more data. What else did we learn about? We can find the dimensions of the data set. So, it has 53,940 rows and 10 columns, right? We can use the skimr package to skim the diamonds data set. In this case, we do not have skimr installed, so let's go ahead and install skimr. So this is a very useful package, and it gives you a very quick overview of your variables and your data. So there we go, right? The name, number of rows, number of columns. So we have 3 factors. So that's good to know. So because this data set has been given to us, through a package, people, whoever prepared it took the time to convert character vectors into factors and hopefully even order them, and because remember, so this is a very good example of the importance of factors. Remember, factors are basically just character vectors that have an order for the different types that are possible for the values. So let's go down into here, for example, like clarity, right? So there is a clear order, like this is lower than this, and this is lower than this, so on and so forth. And the highest one is this. So there is an order to these, even though these aren't numbers, right? And that's where factors come in. That's where you're able to define that order, using a factor. And then we have 7 numeric columns, and then these are the factor columns. So we have cut, color, clarity, and we can see abbreviations for all the different possibilities for each and the counts for each, okay, which is very useful. So basically some of this information here is included in here. And then we have the numeric variables, and then we can see that, first of all, it's very good that there aren't any missing values in any of these columns, so we don't have to worry about dealing with missing values. And on top of that, we can see the means. So this is useful, right? We can see the average of each. So we can see the average diamond would cost, almost $4,000. And then we have the different percentiles, standard deviation, and the histograms, the distribution. We're going to be viewing these in more, in depth through ggplot2, but this gives you a very good quick overview or insight, right? And gives you an idea of what to do as the next step in your analysis. And then obviously, you can just view the data using view, right? And there we go. We have all the data, and we can click on. So let's just go ahead and run this again. I ordered it on accident. But if you click on filter here, you're able to get general sense of the distribution, the min-max values for each. So here you can see all the all the options for cut, all the options for color, all the options for clarity, the distribution. So depth in general, like it does seem to be a pretty even distribution, and these are the ranges. And then same for table, and then for price. As you can see, cheap diamonds appear to be more common than expensive ones, which is also an interesting observation. By the way, each one of these observations that we're making, like that's what exploratory data analysis is, right? So each one of these observations is giving us a little bit more insight into the data, a little bit more intuition and idea as to what's going on and that kind of stuff. So, and then we can see the distributions of the X, Y, and Z. So we can see that in general, you know, Y values seem to be smaller. I guess there are some values that are very high here, and that's why it shows all of it. But, you know, this is a good indication of the distribution and so on and so forth. So, and we might want to, for example, compare X and Y and to see if there's a correlation between them, or, you know, covariance, like does Y increase as Z increases and so on and so forth. And same with the other variables. So we're going to be doing all of that, but, you know, these are just some ways of viewing your data. You could also do head, right, to view the top 5 or 6 rows, or tail to view the last 6 rows, right? So all of this is just, you know, getting a sense of your data, just seeing your data, right? That's what we're doing here. Now let's visualize distributions. Okay? Now, since we did get a good look at our data, just in general, we know, you know, what we might be curious about. For example, cut, right? You know, I'm pretty curious to see how the counts of cut are, like which cuts have more diamonds in them, and like, and so on and so forth, like which diamonds have, you know, very good compared to like good, and that kind of stuff. So let's just very quickly build a ggplot like so. So we're using the diamonds data set, and for this we'll use a bar graph. Let's do something like this, okay? We're visualizing distributions. Let's start off visualizing categorical variables, okay? So, you know, this is the cut is the first categorical variable, so we'll start off with that, right? And so we're building a bar chart, and let's view the distribution of the categorical variable cut using a bar chart. There we go. And it's very clear, right, you know, that there is, you know, there are some cuts that are very rare and some that are very common. So ideal, the cut ideal, the value of ideal is the most common, and then fair is less common, but very good, right, which, you know, most people would be okay with a very good diamond, I guess. I'm not sure exactly what that corresponds to in terms of like technical quality, but, you know, that happens to be a very good amount, right? Premium is even more, in fact. And so this gives us an idea of this variable here, this categorical variable here. Basically, the height of the bars display how many observations occurred with each X value, right? So with each of these, with each cut value. So we can compute these values manually using count from the plier, right? If we take diamonds and we pipe it into count and we count the cut, right? And you have to spell the names right, obviously. So there we go. So this is how we would calculate the values manually, right? So fair is 1,610. So that's 1,610 here. And then, you know, very good is 12,082. 12,082 looks about right. And then we have ideal 21,551, and, you know, that again looks about right. So we're able to calculate them. We don't exactly need ggplot2. ggplot2 just lets us visualize it in a good way, but we can arrive at the same conclusions. But sometimes just seeing it visualized is just more intuitive, right? Another way to do that would be, you know, using the table, built-in table function. And for that, we need to supply a vector. So we remember $sign is used to extract a column as a vector from the data set. So as you can see, we've extracted it. And here we can see that it's actually, it has levels. So it is a factor and there is an order to it. So fair is the worst kind of diamond, and ideal is the best kind. Apparently, I didn't know that. So apparently ideal is better than premium, and premium is better than very good. So this is ordered according to the factor levels. That's interesting, right? That we have best kind of diamonds are the most common. Now, obviously, this doesn't say anything about, we don't know what the process was for acquiring these diamonds in the first place, but it's still interesting, right? One would have expected, the opposite, right? That as the quality of the diamond gets better, it's harder to find, it's rare, right? So yeah, that's interesting. But now, we can use a built-in table function and we can get the same counts, right? But this, the table function basically just counts in a vector the different occurrences, number of occurrences for each value.